Hello, everybody, and welcome to the Chapter 4 review. So we should have a packet that looks like this, and it should have learning target 1. I can identify corresponding sides of similar figures and compare their ratios. All right, so hopefully this is the correct one, and your sheet looks like this. So we're going to complete this packet because it'll help us prepare for the Chapter 4 test that we're going to take later today. All right, so here we go. First question, are the following rectangles similar? If not, explain why. And if so, explain what ratio the triangle ABCD, so this triangle here, was enlarged to create rectangle UVWX. All right, so first thing I'm going to need to think about is, do we have proportional ratios? In other words, if I were to write the ratio for that big rectangle, it's going to be that first side, 24, and 18. Okay, so those are my two sides of my bigger rectangle, UVWX. And now I'm going to put the sides of my smaller rectangle. And so here, the side 12 matches up with 24. So 12 is going to go underneath 24. And 8 matches up with 18. So I'm going to put 8 underneath 18. So now we're going to see, are these two ratios equivalent? Because what we're trying to do is figure out if we can multiply this top number by a number and then also multiply this bottom number by that same number. So let's go ahead and do it. 24 over 12, well, that would reduce to 2 over 1. So I would need to multiply 12 by 2 to get to 24. Let's see if we do the same thing with the other sides. So here we have 18, and we're going to divide it by 8. Well, when I do 18 divided by 8, that gives me a number that's bigger than 2. In fact, it gives me 2.25 over 1. So since these are not equivalent, then we can tell that they are not similar, all right, because we don't multiply by the same number. So not similar, different ratios. And now we're all good to move on to the next problem. So here it says, I can solve problems involving scale factor drawings and geometric figures. So here we have a map, and this map has Reedville, Central City, and Coopertown. And it says, determine the number of miles from Coopertown to Reedville. All right, so I'm looking at Coopertown to Reedville, so that's this distance right here in green. So that is 1 3/4 inches. Well, in order to figure out how many miles it would be in real life, I need to figure out how much 1 inch represents. But cool enough, it tells us right here. 1 inch equals 16 miles. Okay, so let's see. If 1 inch is 16 miles, so I've got my inches on top, my miles on bottom, then what would 1 3/4 inches be? I'm going to change this to 1.75. All right, how many miles would that be? So I'll put X in for that missing value. And so here, let's think about this. Well, I need to multiply 1 by 1.75 to get to 1.75. So I'm also going to have to multiply 16 by 1.75. And let's see what that equals. So I do 1.75 multiplied by 16. Right, my inches multiplied by how many miles 1 inch represents, and that gives me 28. So 28 would be the number of miles from Reedville to Coopertown based off of this scale here. And you could have solved it a different way. If you wanted, you could do something called cross multiplication, where you do 16 times 1.75 to get 28, and then you could do 1 times x to get x, or 1x. And then it says that 28 equals x, which is our missing miles. That's a little bit of algebra there, but either way, you're going to get 28 miles, and you can show it using those two methods above. All right, now we're going to scroll down to the following triangles are similar. Find the length of the missing sides. Okay, well, when it says they're similar figures, that's telling me that they have equivalent ratios. All right, in other words, corresponding sides like 32 and 16 that equals 2 if we divide them. So that means we have to multiply 16 by 2 to get to 32. That also means we're going to need to multiply 9 by 2 to get to x, and multiply 15 by 2 to get to y, okay? Because they are equivalent ratios. So, what number divided by 9 is going to equal 2 is what we need to figure out here. So we can figure out side ED. Well, 9 times 2 equals 18. So x here equals 18. And now let's do side DF, or the missing value of y. So here we're trying to figure out what number divided by 15 equals 2. So when we do 2 times 15, it gives us 30. So y equals 30. And now we have all of our missing sides, and we've shown our work too. All right, moving on to problem 5 here. This is all about proportional relationships. Okay, so we're going to look at graphs, tables, and situations to determine whether or not it's proportional. So here we have an equation to start. Now remember, this is y equals k, which is our unit rate or constant of proportionality, multiplied by our x value plus 4. And if you're like, wait, what is this x? What is this y? Well, remember, if we look at a table or a graph, we're going to have our x, which could be minutes. All right, so here we have our minutes going across if we were to create a graph. And then we have miles, our y, which would be going up and down our y-axis. And so here you could graph it. You could say at 2.4 minutes, at 4.8 minutes, and at 9.6 minutes, we are at these corresponding values of, say, 1, 2, and so on. All right, so here we have, starting at 4, we go up 3 multiplied by x each time. All right, well, if I'm looking at proportionality, I have to make sure there are 2 parts that it covers. It needs to be a straight line. In other words, it needs to have a constant of proportionality, or a rate, which we see here. It does have a rate. But then it also needs to start at the origin 0, 0. Okay, does it start at the origin? Well, here it does not, because it starts at 4. So, since it checks off that first thing, but doesn't check off that second box because it doesn't start at the origin, we can say it's not proportional. How do we know? Starting at 4, not 0, 0. Remember, 0, 0 would be right here on the origin. In this example, we'd be starting up here at 4, which we can't do. Okay? Now we move on to the table. Well, first off, do we start at 0, 0? Yep, right here, right? We see 0 for our x, 0 for our y. We could write it as an ordered pair if we wanted. And then, does it go up by the same each time? Well, it goes up by 2.4 here. And it goes up by 2.4 here. And I know it doesn't look like it's going up by 2.4 when we go from 4.8 to 9.6. But think about it, we're jumping from 2 to 4. So if we were to include that missing part here, which would be the third mile ran, Well, then we could add 2.4 to 4.8, which would give us 7.2. And hey, look at that. We are going up by 2.4 each time. So it does appear to be proportional. And when it says, how do you know? You could say, goes up by the same each time, or you could show your work. You could do 2.4 over 1 equals 4.8, our minutes over our miles ran. 9.6 over 4, they all are equivalent because they all equal 2.4 over 1, meaning that you can run 2.4 miles in 1 minute. Okay, so miles per minute. That's our unit rate. And then we also know that it starts at the origin. All right, now we're looking at the third situation. It starts off by saying it costs $8 to get into the amusement park. After that, it costs $2 per ride. Well, if we wanted to set this up, we would do y, which would be our total, equals k, which is the cost per ride, our unit rates. And then we have how much we start with, which would be over here, $8. Well, since we're starting at 8, this would make it not proportional because this is not the origin of 0, 0. In fact, when our x is at 0, our y is at 8 because that's what we're starting at on our graph or our table. We're going to start way up here with our y at 8 because it costs $8 to get in. So not proportional, not starting at origin. All right, explain what a variable is. Well, if we look at variables like down here or in some of the problems we solved up here, it is a placeholder for a missing number or an unknown number. You could even give an example like 3 plus x equals 5. X would represent 2. All right, it's just a placeholder for that missing number. Now we're going to simplify these like terms. Okay, so what I'm going to do is I'm going to circle the terms that have the same variable raised to the same power here. So 7x squared, then there's negative 5x squared. That would give me 2x squared when I combine them. And then I have 3x squared, or 3x, excuse me, plus x plus x. So here I have a total of 5 x's. And then over here we have 3 plus negative 3. Well, they would cancel out, and so we wouldn't have anything extra. This would be my final answer. All right, go ahead and try these next two on your own. So pause the video and go ahead and try them. All right, let's talk about them. So first we have this one here. I'm going to circle all my x's. And notice I'm including that sign before the x's because that's really important. Here's a 2x, 3x. Okay, so positive x plus negative x, that would cancel out. And then 3x minus 2x, or 3x plus negative 2x, would be just one positive x. And we can write that as simply x. And then we have 5x squared. That stands alone over here. And I'll do that in a different color for you. And then we have plus 7 minus 2. So 7 minus 2, that's going to give me positive 5. So this would be my simplified version of what's above. All right, we got to try one more here. So let's circle all the x's. 3x, 6x, negative 2x. So if we combine 3x plus 6x, that's going to give me 9x. And then I'm going to subtract that 2x still. So here I have 7x. And then over here I have negative 10 minus 4. Well, if I'm at negative 10, and then I go even more in the negative direction, 4 spots, I'm going to end up at negative 14. So minus 14 at the end. And then in between there we have 4x squared plus negative 3x squared. So that's going to give me 1x squared. Throw a plus sign in between. And then here I have my subtract 14 at the end. If you wanted to, you could make this plus negative 14. Either way works. All right, so if you also wanted to get rid of the parentheses and keep it as 7x plus 1x minus 14, or simply 7x plus x squared minus 14, all those ways work, okay? So thank you very much for watching this video. Hopefully it helps you on the test today. Good luck, all right? This is the last test, so try your best, and thank you so much for these 4 weeks. All right, later.